Hello everyone, let's discuss the concept of Lenzs law. So we all know that what is the magnitude of statically induced EMF, which is equals to minus n d phi by dt. So in this formula, this negative sign represents what? Direction of statically induced EMF, which is explained by Lenz's law, right? Then what is Lenz's law? So coming to the statement, according to Lenz's law, statically induced EMF in a direction which opposes the changes in flux linkages which produces that EMF. So according to Lenz's law, statically induced EMF, which is due to what? Flux linkage, right? This statically induced EMF in a direction which opposes the changes in flux linkages which produces that EMF. So simply effect oppose the cause, right? This is a simple statement of Lenz's law, but here the effect is what? Statically induced EMF. Here the cause is what? Flux. Here the effect oppose the cause, but induced EMF is, that is electromotive force, is electrical quantity, and flux, which is nothing but magnetic flux, right? Flux is magnetic quantity. Then how can this induced EMF should oppose this flux? Because EMF is electrical quantity and flux is what? Magnetic quantity. Question is what? How an electrical quantity ES oppose changes in magnetic quantity flux? This is the question for us. So in order to get clear idea, because EMF is electrical quantity and flux is what? Magnetic quantity. So what is this answer? What is the answer? Statically induced EMF will not oppose flux directly. So the EMF is opposing the flux indirectly. What is that meaning? So statically induced EMF will not oppose flux directly as both are of different nature, right? Because one is electrical quantity and another one is magnetic quantity. So initially, because of flux linkages in the conductor, EMF will be induced, right? So that EMF in the conductor makes the current to flow. So how it is indirectly oppose the changes in flux. So for that, initially, because of flux linkages, an EMF is induced and which makes the current to flow. So the direction of induced EMF and direction of current are same. And same. So now the conductor acts as current carrying conductor placed in a magnetic field. So the direction of current in the conductor can be known by using right hand thumb rule. So here, because of the flux linkage, an EMF will be induced which makes the current to flow. The direction of ES and direction of current are same. This current is responsible to produce the flux. So this flux opposes the changes in main field flux. So now phi C opposes the changes in main field flux. So simply, what is recall? We have statically induced EMF. So initially, because of flux linkages, we have an EMF will be induced. So because of this EMF, we have current. Because of this current, we have flux. This flux is nothing but this flux. So indirectly, this EMF should oppose the changes in main field flux, indirect. So this is indirect method. Current is due to ES, this phi C is due to current. So this phi C is opposes the changes in main field flux. This is about Lenz's law. So we all know that how we can distribute the strengthening flux or weakening flux. So let us say during this period and during this period flux is strengthened, right, in positive half cycle. Like that, during this period from here to here, strengthen in negative direction, right? Like that, in positive half cycle, in this period, weakening in positive direction. Like that, from this point to this point, weakening in negative direction. So if we consider an AC curve during this period, flux is strengthening in positive half cycle, like that from this point to this point it is weakening, like that in reverse direction it is increasing, it is strengthening in reverse direction, like that from this position to this position weaken in negative direction. So in order to get clear idea about Lenz's law, we have to deal with two cases. Before that, case 1, that is time varying. What is case 1? Main field flux is strengthening with respect to time, because time varying magnetic field. Main field flux is strengthening with respect to time. So for that I am going to get a single circular conductor. This is single circular conductor, right? So we have conductor, obviously we are going to get the magnetic field. This is what? Magnetic field. Main field flux is strengthening, that is time varying magnetic field. So obviously we have magnetic field and conductor. So let us say here the main field flux is strengthening. So in order to oppose that main field flux, the phi c should be x downward direction, right? Because the main field flux is strengthening. This is phi c. Phi c should opposes the changes in phi m, main field flux. So here main field flux is strengthening with respect to time, that's why it is acting downward direction. So let us say this is the current direction, obviously this is current direction, obviously this is the direction of statically induced EMF. Current and statically induced EMF direction is same. This is ES. Flux is phi c like this, main field flux is upward direction. So the current in, we can write that the current in conductor produces the flux phi c, right? This flux should oppose the changes in main field flux, because the main field flux is strengthening in nature. In order to weaken that effect, the corresponding phi c should be acting in downward direction, that is phi c should weaken phi c should weaken phi m, right? According to this, the direction of phi c is determined, that's why it is acting downward direction. So statically induced EMF indirectly opposes the main field flux. This is about the concept of Lenz's law. This is case 1. Now in case 2, main field flux is weakening with respect to time. Case 2, what is main field flux is weakening or decreasing, we can say decreasing with respect to time. So we have a circular conductor and we have a field, we have a magnetic field, but what is the strength of this magnetic field? It is weakening. The strength of the magnetic field is very weak. So in order to oppose the changes in magnetic field, the corresponding phi c should be x upward direction. In order to strengthen that phi m, the phi c should be x upwards. Phi c. So what is the main reason here? What is the direction? This is, let us say, now it is ES. Let us say this is the current direction. Okay, we can write that point. Here phi m is weakening in nature. So the direction of phi c is in such a way that it should strengthen main field flux. That's it. Here the main field flux is weakening. So in order to oppose the changes in main field flux, the corresponding phi c should be x upward direction. So this is about the concept of Lenz's law. So finally I would like to write the corresponding statement of Lenz's law. What is the statement? According to Lenz's law, direction of statically induced EMF is such that it causes current in a closed loop, right, which in turn produces flux, right, which in turn produce flux which opposes, this flux is nothing but phi c, which opposes the changes in main field flux phi m, which is responsible for production of, which is responsible for production of statically induced EMF. This is about the concept of Lenz's law. Thank you.